Hello and welcome to another geometry lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 4, Lesson 4 on bisecting an angle. So yet again, what we're going to be doing is looking at a construction that serves a particular purpose. In this case, bisecting an angle. So let's get right into that particular construction. Angle bisectors. One of the fundamental assumptions in geometry is that every angle has a unique bisector, i.e. one line that divides the angle into two angles of equal measure. So let's see how to do that in exercise number 1. Given angle A shown below, do the following. Letter A. Draw an arc with a center at A that intersects both rays of A. Mark the intersections as point B and C. What is true about these 2 points relative to point A? All right, simple enough, right? This is actually identical to how we started with copying an angle, right? We just want to come over here, draw a nice little arc. Just got to make sure that arc intersects both rays of the angle. Now, in this particular case, they tell us to mark those points as B and C. Now, what is true about points B and C compared to point A? Well, because they both lie on the same arc with A at the center of the arc, they must be the same distance away from A. We call that equidistant. So they are equidistant. Let me try to make that Q a little bit better. They are equidistant from A. Right, I could even mark it. I'm not going to for right now, but I could mark it, but I am going to make that look more like an A. There we go. Okay, let's take a look at letter B. Using points B and C as centers, draw 2 arcs of the same radius that intersect. This radius does not need to be the same as the one that you had in A. Mark their intersection point as D. What is true about point D? Okay, so again, let me distill all of this down for you. I want to now take my compass. I can leave the radius the same as it is now, or I can change it. I'm going to change it a little bit just to show you it can be changed. And I'm going to draw an arc with a center at B, somewhere out here, and I'm going to draw an arc with the center at C, somewhere out here. You just got to make sure the 2 arcs intersect. Okay, so I'm going to actually make this a bit bigger, again, just to show you that you can. Or maybe I'm not going to make it a bit bigger. Well, okay, first thing I'm going to do is I'm going to draw my arc with a center at C. Or I'm going to try to draw my arc with a center at C. There we go. I don't know why, but my pen was not happy with me. Okay, now let's draw the same arc, or not the same arc, but an arc with the same radius whose center is at B. There we go. All right, great. And I'm going to mark this as point D. Okay. Now, what is true, right? What is true about point D? Pause the video now and see if you can write something down. Well, now point D is the same distance from B as it is from C because I have the same radius, right, from both of those 2 centers. So D is now equidistant from B and C, right? So that one point is the same distance from B as it is from C. Now, letter C. Draw a ray starting at A that passes through point D, i.e. ray AD. Use tracing paper to verify that AD bisects angle BAC, i.e. that angle BAD is congruent to angle CAD. All right, so the final thing, right, to finish our angle bisector construction is we're going to bring our straight edge up and we're simply going to draw a ray that goes through A and goes through that intersection point. And it probably is pretty clear that that is, in fact, the angle bisector. All right. Now, what I did was I basically just took half the angle and I created half the angle. So in other words, right, there it is, right? It has definitely bisected that angle. We could even bring out a protractor and kind of measure this angle compared to that angle to see that they are, in fact, congruent. All right? Now, let's take a look at exercise number 2 and make sure that we understand why the proof or why this construction works, right? We want to know why a construction works. Let's take a look. Fill in the missing reasons below in the proof of why AD bisects BAC. Now, almost all of our proofs need to involve triangles. So I put in additional segments going from point B to point D and point C to point D. Now I drew them in dashed just because we didn't have them on our original construction, and they don't really need to be there when you do the construction, but they're going to help us with this proof, right? So I'd like you to pause the video now and see if you can fill in the reasons for why this particular construction works. All right, well, the first one, AB is congruent to AC, that's by construction. I'm going to actually mark that right now. Those two are congruent. All right, my second line, BD is congruent to CD, that is also by construction, right? We set that particular radius and we made sure that it was the same. Now, why is AD congruent to itself? Well, that's simply the reflexive property, right? So then I can say that triangle ABD, right? Triangle ABD is congruent to triangle ACD, right? ABD is congruent to ACD, and that's by the side-side-side congruence theorem. We didn't actually use side-side-side that much in our triangle proof unit, the last one, right? But boy, it's coming up a lot in these constructions. Now, we can say that angle BAD is congruent to angle CAD, for one of our favorite most used reasons, CPCTC. And now, because those two angles are equal, we can say that AD bisects angle BAC by the definition of an angle bisector. Isn't that cool? So we actually create an angle bisector by creating two congruent triangles, right? We could create these two congruent triangles, which then forces this angle and that angle to be congruent to each other, which then forces that to be the angle bisector. Really kind of cool. It's one of my favorite constructions. It's very simple, very easy to do. Let's go through it again. Exercise number 3. Using only a straight edge and compass, construct the angle bisector for each of the following angles. Leave all construction marks. Okay, let's go through it again together in letter A, and then we'll have you do letter B on your own. All right, so step number 1. I am going to draw an arc whose center is at the vertex of the angle that I'm trying to bisect, and the arc then intersects the two rays of the angle. All right, now remember, that is to establish 2 points on each, 1 point on each of the rays that's equidistant from that vertex point. I then can move the compass out here, and I think this time I'm going to just leave the radius the same, because you can, or you can change it. We just have to draw it. Actually, here I think I'm going to make it a little bit longer. We have to make it long enough that we're going to get an arc out here, and it slipped a little, an arc up here, and then we will move our compass, not change the radius from that one, right? And now we want it to intersect right there. Now that is establishing, right, a point that is equidistant from those two intersection points, right? And once we have it, then we've got our angle bisector. That's it. All right. So we draw an arc that establishes two intersection points, right? 2 points that are equidistant from the vertex. We then, using that radius or some other radius, draw an arc using that as its center, right? And that as its center. And where those two intersect will be a point that lies on the angle bisector of angle E. So we simply connect E to that particular point on the angle bisector, and we've done it. We've bisected the angle. All right, let's see if you can do that with a nice right angle R. See if you can bisect angle R. All right, well, let me give myself a little more room here. Actually, that's pretty much it. I'm going to extend the page a little bit. All right, here we go. Step one, bring my compass over, put the pointy end there, enlarge it, draw an arc that goes through both of the rays, move my compass over. All right, yeah, great. Get a nice arc there. Bring the pointy end here. There we go. X marks the spot. Move this away. Bring this down. And we've bisected the angle. All right, each one of those should be a 45-degree angle if angle R is a right angle. All right, pretty simple. Now we're going to move on to something very related, but might seem a little different. Let's talk about a special case. Now, there's a special case of bisecting an angle that arises quite a bit. Before we introduce it, recall the following fact. Perpendicular line through a point on a line. Only one perpendicular line can be drawn through a given point lying on a given line. In other words, if we've got some line M, and we've got some point A that lies on line M, there is one and only one line that can be drawn through A that is perpendicular to M. And that's what we're going to try to construct next, okay? If we've got a point lying on a line, we're going to try to construct a line that is perpendicular to the line given and that passes through the point that lies on that line. All right. Now you might wonder, what in the world does this have to do with bisecting an angle? Well, let's take a look. Exercise number 4. In the diagram below, point C lies on line AB. Letter A. What is the measure of angle ACB? Oh, this should be easy. Pause the video now and go ahead and write down what the measure of angle ACB is. Well, since C lies on line AB, point A, C, and B must be collinear, which of course then tells us that the measure of angle ACB is 180 degrees. All right? Letter B. Construct the angle bisector of angle ACB. Leave all construction marks. Okay, so I just want to bisect angle ACB. I mean, we just did angle bisectors, so let's do it. Let's see, how did that work? Let me just bring this up a little bit so I have a little more room. Let's see, I had to put the tip of my compass here, right? I had to open the compass up and draw an arc that intersected the two rays of the angle. Then I needed to put the compass on one of those intersection points. I think I'm going to make it a little bit larger this time. And I needed to draw an arc. There it is. I needed to draw an arc from that point, and without changing the radius, I then needed to move my compass over and draw an arc from this point, right? And then I draw a line through point C, right, that then passes through that intersection point. Come on. And that will have bisected the angle, right? I just bisected angle ACB, right? I literally did exactly the same construction that I've just been doing. I think the only difference between what I just did and what we were doing over here is that over here, I didn't sort of extend the line past the vertex of the angle. I just started at the vertex and went through the point. And of course, I could have done exactly the same thing here. Let me bring that back, right? But I actually extended the line below it. Now, letter C. Explain why this angle bisector must be the unique perpendicular line to AB that passes through point C. So why is that? Pause the video now and see if you can write something down. Well, it's pretty simple, right? When you bisect a 180-degree angle, the two angles that you get are both 90 degrees. And because they're both right angles, that line must be perpendicular to that particular line, and it must pass through point C because point C was the vertex of the angle, the 180-degree angle, right? So let's write this down. 1/2 of a 180-degree angle is 90 degrees, or a right angle. So the line must be perpendicular to the original line and passes through C. More red. Look, if you even just said, hey, half of a 180-degree angle is a right angle, I'm so good with that, right? I mean, that's the whole point, right? That's a right angle, that's a right angle, of course, that's a right angle, and that's a right angle. So, you know, it's weird because I think that a lot of times students will view the angle bisecting construction and the perpendicular line construction as two different constructions. But they are literally identical constructions, right? This is just a very specific example of the bisecting construction where you happen to be bisecting a 180-degree angle, a straight angle, and therefore the angle bisector must be perpendicular to the line that you're drawing it to. All right, so let's get a little bit more practice with that. Pretty simple. All right, let's do the first one again together. Exercise number 5. For each line shown below, construct a line perpendicular to it that passes through the marked point on the line. Extend lines as needed. Leave all construction marks. All right, here we go again, right? Again, here I don't have, points B and C, but it doesn't really matter. I want to look at point A as if it's the vertex of a straight angle, a 180-degree angle. So I'm going to come over, bring and put my compass on the vertex of that 180-degree angle. I'm going to open my compass up, draw some arc that passes through both rays of that 180-degree angle. Right? Then I'll kind of bring my compass over here. I tend to make these a little bit more lengthy. Bring my compass up. I think I'm going to even have to make it lengthier than that. All right, get a nice arc. Bring the compass over here, same radius on that arc. All right, and I now have a point that I can connect with A that will bisect that 180-degree angle. The biggest, I think, difference here is I really want to draw a line that extends not just from point A through that point, but actually all the way down. And I'm going to throw that right angle in there just to kind of emphasize that idea. I now have a perpendicular line that passes through point A. Isn't that cool? Again, all I'm doing is bisecting this 180-degree angle. That's it. So, what I'd like you to do now is the same thing here. Construct a line that is perpendicular to line K and passes through line Q. Now you may decide that you want to extend line K up in this direction some. That is completely okay if you need to. Pause the video now and go ahead and make it through this construction. All right, I'm going to see if I can do it without extending the line. We'll see. I just have to make sure that my arc somehow is small enough that it doesn't extend past that. Again, we're working in two different mediums. I'm working, of course, in an electronic medium. Okay, now I want to put my compass at one of those points. Again, I think I'm going to make it a little bit longer. Let's move this out of the way for right now. I think even a little bit longer. I like to have my arcs intersect outside instead of inside of the original arc. Move this over here, rotate it up, and there we have it. X marks the spot. Bring my straight edge in, and pretty close. Almost made it right through Q. There we have it, right? A perpendicular line 2K that passes through Q. I really want to emphasize no different than what we started the lesson with in terms of bisecting an angle. So let's summarize, right? Today we learned how to bisect an angle. Simple enough, right? It's all about drawing 3 arcs. One arc that intersects the 2 rays of the angle, and then 2 more arcs of the same radius whose centers are at those intersection points. Their intersection point then locates a point on the angle bisector. Once you connect that point to the vertex of your original angle, you will have the angle bisector itself. The only difference between that and constructing a perpendicular line through a point on a line was that in that case, we were truly just bisecting a 180-degree angle, okay? So we'll get more work with bisecting angles in a variety of different lessons in this unit. For now, I just want to thank you for joining me for another geometry lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.